Today we'll talk about absolute value functions. So they look different. We've been doing a lot with linear equations, but this is what absolute value functions will always look like. They'll either look like a V or an upside down V. But the main goal of today's lesson is actually to help you start seeing how adding, subtracting, and changing a sign will actually affect how a graph looks. So, for example, the original function, this can be called the parent function, absolute value of x. It's called the parent function because nothing's happening to it. Nothing's being added, subtracted, multiplied, divided. There's no negative sign. So this is kind of the original. So it has a vertex. The vertex is the part where it changes direction. So it's really kind of two straight lines, but it has a corner, and that corner is called the vertex. So for the original function, the vertex is right at the origin, and then it follows straight up. It just goes up 1 over 1, up 1 over 1, up 1 over 1, and so on. And then does the same thing in the opposite direction over this way. So that's what the absolute value of x looks like. And what makes it flip upside down is when you have a negative in front. So notice the negative is not inside the absolute value, it's outside the absolute value. That makes it flip upside down. The vertex is still in the same spot, but it's almost like it gets mirrored to go down instead of up. Now we'll talk about why. Actually, let's go ahead and fill this in, then we'll come back to number 3. So like I said, the absolute value of x is the parent graph. It's the starting point. And if you have a negative in front of that, it turns the graph upside down. Okay, now there's two ways you can add or subtract a number here. You can either add or subtract a number inside the absolute value, which is what these first two are talking about, or you can add or subtract a number that is outside the absolute value. So when there's a number being added or subtracted inside the absolute value, that's going to shift the graph horizontally. When we add, it shifts it to the left, and it shifts it to the left this number of units. So if that's a 4, if it's x plus 4, it shifts to the left 4. If we're subtracting 4, it shifts it to the right 4. So when you have it adding or subtracting inside the absolute value, it shifts it horizontally. Plus left, minus right. And honestly, that might seem backwards, because we know like this direction is positive on the x-axis, this direction is negative, so this often seems backwards, and I understand that, but I just say try to remember that when it's inside the absolute value, it's backwards from what you think. Now when it's outside, it's just like you think. Plus moves it up that many. Again, if that was a plus 4, that means you move the graph up 4 units. If it's minus 4, you'd move down 4. So if you can just put these things in your mind, this upside down part 2, these 5 things, you can do these questions very easily, because all we're trying to do is graph them on this. So as you look at number 3, we're imitating this one right here, x minus a number. I know you might know that as a hashtag, but it's also the symbol that before hashtags were a thing, the symbol that meant number. So this is x minus 2. So minus means we move to the right. So while the origin is normally, the vertex is normally the origin, we've got to move to the right 2 units and draw the vertex there. So minus 2 inside the absolute value means we move to the right 2. Okay, on number 4 down here, this is another one that's inside the absolute value, so it's going to be a horizontal movement. Plus means move to the left, so I go over 1, 2, 3, 4, and I draw my graph. Okay, so now we're switching gears and going outside the absolute value. This is when it's a vertical movement, either up or down. When it's plus, you move up that many. So start at the origin, move up 2, then draw your V. Six, we're subtracting 3 outside the absolute value, so it's a vertical movement. So we're going to move down 3. Let's move down, start at the origin, move down 1, 2, 3. And like all good math teachers do, now we complicate things and do more than one. Whew. Okay, so let's look at this one at a time. This minus 1 that's inside the absolute value. So minus 1 inside the absolute value moves us to the right. So we'll move to the right 1. Then we have plus 2 outside the absolute value. So when we're adding outside the absolute value, we move up. So this tells us to move to the right 1, and this tells us to move up 2. And truthfully, it doesn't matter which order you do that in, you'll get the same result. So we start at the origin, and I move right 1 and up 2. Okay, this is a little hard to see, sorry because of the copy, but that is a negative right there. So that negative tells us to go upside down. And that minus 3 inside the absolute value tells us to move to the right 3. And again, you can do this in either order, but I'm going to move to the right 3, 1, 2, 3. But this time, since I flipped upside down, I'll draw the graph as an upside down V. And sometimes they might ask you to do 3 things. Crazy. So the negative makes you go upside down. The plus 2 inside the absolute value means you move left 2. And the plus 3 that's outside the absolute value means you go up 3. So I'm going to go left 2, always start at the origin, left 2, 1, 2, up 3, 1, 2, 3. There's my vertex, my corner, and I draw an upside down V. So it will take some memory to remember where it is and what means what as far as the signs, but once you put that in your memory, it's pretty straightforward.